Let's continue our discussion about deterministic finite automata or DFA. So let's have this example 1. We're going to design a automaton or a DFA that accepts settable strings that start with 0. So for example, 0, 0, 0, 0, 1, 0, 0, 1. So as long as the string starts with 0, it will be accepted. Okay, so now let's draw the design. So definitely our automaton will start with the initial state. So let's call it state A. And if the first symbol of the string is 0, definitely it will go to a final state. Okay, why? Because if we only have 0 as a string, it's already been accepted. Okay, so that's why A encounter 0 will just go to the final state. And after the first symbol, anything after 0 will just loop within B. Okay, but in case if the string starts with 1, where will it go? So start with 1 means it's rejected, not accepted. So it should go to a trap state. So let's call it set C. Anything after 1 will be looped in set C, since it's already been rejected because of the start bit. Okay, again, C is a trap state or a dead state, wherein all rejected strings will just fall in C state. All acceptable inputs or acceptable strings will be on B. Okay, so let's check how do we determine if a string is rejected or accepted. So let's start with this input 0, 0, 1. So how will it navigate within our automaton? So again, initial state, which is A. So first symbol 0, definitely it will go to B. And then second 0, since we're already in B state, it will just go to itself, which is B. And for 1, again, loop within itself. So final state is B. So therefore, since we fall or we stop on the last state or the final state, 0, 0, 1 is accepted. Okay, so how about 1, 0, 1? So initial state A, it accepts 1, definitely it will go to C. And then after C, so we have 0, it will just loop within itself, so therefore it will go back to C. Then for 1, it will go back to C. Since after the first bit, all is trapped in C, and C is not a final state. So therefore, this is rejected. 1, 0, 1 is rejected, not accepted by automaton. Okay? So now, let's define the 5 tuple of this automaton. So Q, the sets, same collection of sets of our automaton, A, B, C, sigma, alphabet, 0, 1, Q sub 0, our initial state, A, final state, B, and R, delta, our transition function. So that's it for example number 1. More example on the next video lecture. Thank you.